All right, let's just dive right in. Every once in a while you stumble upon a project that's so big, so ambitious, and, let's be honest, so strange, you just have to stop and ask, what is going on here? Today we're going to unpack one of those, a real technological enigma from a company called DART Meadow.
It all kicks off with this. At first glance, it looks like a recipe, right? It's a list of ingredients for some kind of specialized hypersonic alloy. You've got tungsten, nickel, silicon, pretty standard stuff for high-tech materials. But trust me, this is just the tiny tip of a very, very big and very weird iceberg.
Because then you see this, a list of natural tools for an AI, and they're in a super specific order. Maze, puzzle, envelope. What on earth could these possibly have to do with making metal for hypersonic engines? It feels totally, completely random.
And that right there, that's the central mystery we're going to solve. How do you connect these completely different dots? Well, it turns out there's a powerful, unifying logic behind all of it. But to see it, we have to follow the breadcrumbs, so let's do it. So here's how we're going to break it all down. We'll start with that mystery alloy. Then we'll uncover the core philosophy that's driving everything. After that, we'll get into the AI software and its custom-built hardware. And finally, we'll put all the pieces together to see the one single grand vision.
Okay, first up, let's start with the most concrete piece of this puzzle, that weirdly named hypersonic alloy. It's our first real clue into what's happening on a much bigger scale.
The first thing you need to know is that all this stuff, the alloy, the AI tools, it's all coming from the same place. A couple of interconnected companies, DART Meadow and Radical Deepscale. And they're working across aerospace, software, and hardware. So what looks like a bunch of random projects? Yeah, not random at all. It's all part of one big, coordinated effort.
And this is where we get our first big aha moment. That name, T11ZC, it's not just a random part number, it's a formula. T is for tungsten, easy enough. 11 tells you the 1-to-1 ratio of nickel to silicon, but then it gets wild. Z and C refer to these incredibly specific processes, like the physical alignment of zinc over calcium and something they call a season function for the calcium. Now, we don't need to be material scientists to get this part. The point is, there's a deep, systematic logic here. This isn't chaos. It's a system.
So if they have a whole system just for naming an alloy, you have to wonder, what's the system for everything else? And that question brings us to the core concept, the key that really unlocks this whole thing. It's a philosophy they call the lead-edge ash tree reflex.
So here's the absolute heart of the idea. They are trying to build an AI that does not think in loops like a normal neural network. Instead, it's designed as a reflexive system. The whole goal is for the AI to go directly from a problem to a solution, to literally reflex to the answer without getting bogged down in endless processing or error loops. It's a totally fundamental rethinking of how an AI can actually think.
And this slide just lays it out perfectly. On one hand, you've got your traditional AI, right? It learns by looping through data over and over, getting a little better with each pass. But this lead-edge approach is built to be direct. When it hits a problem, it's designed to just bypass the loop and find another way forward, always pushing straight for a solution.
And this whole reflexive system is built on a really specific hierarchy of 19. Count them, 19 natural orders of operations. And what do you think is at the very top of that list? You guessed it, those 7 natural tools we saw at the very beginning. The puzzle pieces are starting to click into place.
So how does this big idea, this philosophy, actually become software? Well, with that framework in our back pocket, we can finally talk about the brains of the whole operation, an AI they call Autumn.
Autumn is basically the software that brings that whole reflexive, non-looping philosophy to life. It is designed from the ground up, from the first line of code, to think and work according to that unique 19-step hierarchy. And here it is. This is literally how Autumn thinks. It starts with these conceptual tools, maze, puzzle, envelope, to frame the problem. Only then does it move on to regular math operations, and after that, physics operations. This super strict, really unconventional order is the very foundation of how it thinks. So that bizarre list of tools we started with, the mystery is solved. It's step 1 in the AI's thought process.
Okay, but a unique brain needs some unique hardware to run on, right? You can't just run this kind of revolutionary software on some off-the-shelf chip. Nope. So they built their own. And this is where Aerial comes into the picture.
Ariel is a custom-built neural processing unit, an NPU, designed for one reason and one reason only, to be the perfect physical home for the Autumn AI. I mean, the software and the hardware are being created together, completely in sync.
And the chip's design is just as wild as the software. Get this, they talk about radical transistors, where silicon is physically smelted and aligned to perform specific calculations like mass or volume right there at the atomic level. It's insane. They've even got a new circle transistor for fluid dynamics. But the key point is, the hardware itself is built for these reflexes, not for loops, perfectly mirroring Autumn's core design.
Okay, deep breath. We've looked at the alloy, the philosophy, the software, and the hardware. Now let's take that final step back, put all these pieces on the table, and see the one single, breathtakingly ambitious vision that connects it all.
It all flows from one single idea. You start with this non-looping, reflexive philosophy. Then you build an AI, Autumn, based on that philosophy. You design custom hardware, Ariel, that is physically built to run that AI perfectly. And then you point this powerful, unified system at some of the hardest problems you can possibly find, like designing a brand new hypersonic alloy. See, the alloy and the AI aren't two different projects. The alloy is just one of the first things they're having the AI create.
And this quote from their own documents, it just says everything about the scale of what they're trying to do. They're designing an AI that is so fundamentally creative, it's meant to keep working even if the power gets cut off one day. It's a system designed for ultimate resilience. So it started as a super confusing mix of ingredients and tools. It all resolves into this single, incredibly complex, and truly fascinating vision for the future of computation itself.